So this is gonna be 3.1, and I'm going to just go over the worksheet and explain the problems as best as I can, and like in the way that like I kind of process the problems, how like my mental process is, and hopefully it helps. Okay, so for the first few problems that we have here, we are going to be simply solving them through the fundamental counting principle, which is like the first few problems of our notes. And we're able to do that with each of these problems because there's really no other factors or other requirements in these problems like in the other ones for the permutations or the combination problems. So we can just multiply the numbers according to like what we're given in the problem. We don't have to like do the P or the C thing. So like for number 1, we just have to find the total number of ways to reach the second floor. So we just have to multiply 8 by 12, which would give us 96. So like we can see that they're not asking us for like a specific way, or they're not asking us for specific things, or like they're not adding on to like the question. So we can just multiply like that. And then for number 2, we can just multiply as well, the 7 times 3 and times 2, which would give us 42, because there's nothing specific about the problem that makes us have to use a P or the C. Like it's not asking for a specific order or a specific detail. It's just asking us to make it's just asking us how many different outfits are possible, like in general. These are very like general questions, I guess you could say. So then for number 3, we would multiply 10 by 26 and then again by 10, because the problem tells us that the passcode consists of a digit and then a letter and then another digit, and the digits range from 0 to 9. So from 0 to 9 we would get 10 digits, because we would start with 0 and then 1, 2, 3, 4, 5, 6, 7, 8, and then 9. So those are 10 possible digits that we can have in our passcode. And then for the letters, we know that in the alphabet, at least in the English alphabet, we have 26 letters. So since the problem doesn't give us like any specifics, we can just assume that like any of those 26 letters can be used, and like it could be any of those 26 letters. So that's why we're gonna be using the 26 and then the 10 again for another digit. So it would be 10 times 26 times 10 equals 2600, and that would be our final answer. And then for number 4, we are going to be multiplying 6 by itself 8 times. So it would basically be like 6 to the power of 8, because we are rolling the 6-sided number 8 times. So like the first time, we're going to be rolling the 6-side die 1 time, and then the second time again we're gonna be rolling it again, and then for the third time we're rolling the 6-side die number again, and then for the fourth time we're also rolling the 6-sided number. So like since we are rolling that same die each of those 8 times, we have to multiply the 6 by itself over and over again for 8 times, and then it's gonna equal to whatever this big number is. Let me add the commas so I can read it. Okay, so it's 1,679,616. Yeah. So then for number 5, we're going to be multiplying 4 by itself 8 times as well, because the problem tells us that there is 8 multiple choice questions, and in those questions there are 4 options. So since each question has the 4 options, it could be like 4 possible outcomes. So we're gonna be multiplying those 4 possible outcomes by itself 8 times, because there's 8 questions, which would give us 65,536. So yeah, and then for the last one, for number 6, we have to find out what the color, well, like how many colors are available for Jack's new truck. And we basically have to solve this as if we were solving like a missing variable, or like a variable, because in this case the 96 would basically be our final answer if the problem was arranged like one of these problems. So like the 96 would be like the final answer, like it is in here, and our numbers would be 4, and then 2 for his 4 choices of engines, and then his 2 choices of transmission, and then our third number would be basically whatever the color is. So like our 3 factors would be the engines, the transmissions, and then the colors, to give us our final answer of 96. So like the equation would basically be like number 2, but like instead of having the 3 factors, we would have a variable, and then our final answer would be 96. So I basically arranged it like that over here. So I made 4 times 2 times C for the color equals 96. And then I multiplied 4 times 2 equals 8. I brought down the C and then the 96. And then 96 divided by 8 equals 12. So the number of colors that were available are 12. And so 12 would be our final answer. And then for the next set of problems, we are going to be using our calculator for these problems. And I don't know if he wants us to check our, well, not check our work, show our work, but like I will, just in case he does want us to. I'm not sure, but yeah. So like 6 with this little exclamation point. I don't know if it has like an actual name, but yeah, I'm gonna just call it the exclamation point. Would equal to 6 times 5 times 4 times 3 times 2, and then times 1, which would then equal to, let me plug it in, 720. So it would equal to 720. And then for this one, I'm not gonna expand this one, so I'm just gonna plug it in into the calculator. So it would be 16 with the little exclamation point over 7 with the exclamation point again, and it would equal to a really big number. It's 4,151,347,200. So it would be 4,151,347,200. Yeah. So then we would do the same thing for number 9. plug it in on the calculator. And then for number 10, I would simplify it first. So I would do 2 exclamation point 9 over 1. Over, wait, what? 2 exclamation point times 9 exclamation point over 3 exclamation point. And then I would plug it in into the calculator. So it would be 2 exclamation point times 9 exclamation point, and then 3 exclamation point equals to 120,960. So yeah. And then for number 11, we would arrange this, what's it called, permutation in its equation, or like its fraction for its formula. Yeah. So like we would turn this into its formula and then simplify it and then plug it into the calculator for our final answer. And then we would do the same thing for number 12 and then simplify it and plug it in into the calculator. So it would be 15 exclamation point over 15 times 7 exclamation point. And then we would do the exact same thing for number 13 and 14. And plug it in into a calculator for our final answer. And then the explanation for number 15 would just be that for permutations, the order of the arrangements, or like the lineup, does matter, but for the combination, for the combination formula, it doesn't really matter. Like the arrangement doesn't matter. So that's why the what's it called? The answers are like different. So yeah. And then for these questions, as the directions say, we have to determine if the situations are permutation or combinations. And you would identify that, or you would decide that by seeing if the what's it called, the example or the problem gives like the order of things like an importance. Like if it mentions things like in order, like if they have an order, like for example for 16, it says that it says how many ways can we arrange the order in which he does them, whereas for number 17 it just says how many ways can Kelly choose 5 of them. It doesn't really like tell us there has to be an order, or if we have to take the order of things into account. Like the 16 different color markers are just in a bucket, so like you can imagine like the 16 different markers just being like mixed inside the bucket, and then she just chooses 5 random ones. So like that would tell us that it's a combination, because the order doesn't really matter, or like the specifics don't really matter. There's just 16 random different color markers, and then she chooses 5 random ones. But like for number 16, it tells us the chores are like specific, I guess, and then he has to arrange them in an order, in a specific order. So it would use permutations. So like then you would just write the formula for it and solve it using the calculator, or if you can do it like manually, if you feel comfortable doing it manually, you could do that as well, like if it's an easy one. And then so it would be 7p 7. So like this one's an easy one, it's just like that. And then it would be 7 exclamation point in the calculator, and it would give us 5040. So 5040. Yeah. And then for number 16, it would be 16c5 equals 16 exclamation point over 16 exclamation point parentheses 16 minus 5 and then exclamation point. And then that would give us 16 and then 16 exclamation point times 11 exclamation point, which would then give us okay, it would give us 2 point, I'm gonna, what's it called? Reduce the number. I forgot the word, but I'm gonna make the number smaller basically. So it would be 2.5 and then times 10 negative 8. Yeah. So then for number 18, it is also gonna be a permutation because there's specific variables, I guess you could say, because there's a president, vice president, secretary, and a treasurer. And then there's 32 members. So like since we have specific positions, we are going to use the P because it matters the order in which things are placed. Like we can only get one president, we can only get one vice president, and those people are specific, they're set, they only have one position. So it would be 32p and then 1 2 3 4. So 32p4, and then we would solve it. Then 19 would be a combination because there are going to be 3 new dancers from a group of 25. So like those three dancers could be like any of those 25 who try out. So the order doesn't really matter, there's no specifics. So it'd be 25c and then 3. And then 20 would also be a combination because there are 10 random toppings for ice cream, and Max can choose 2, like any 2. So it can be like, I guess, random, like there's no, they don't specify anything. So it would just be 10c2, and then we would solve. And then for number 21, it would be a permutation because there are a specific amount of letters and they are specific letters. Like these, the letters that we're using are set. So it would be, how many letters do we have here? It would be 1 2 3 4 5 6 7 8 9 10 11. It would be P11 11. so it would be 11i, DI11 exclamation point. Yeah, and then for number C, actually for number 21, I'm not sure if we're supposed to be using this one or if we're supposed to be using the one he showed us in the other notes. So let me just check really quick to make sure. Okay, no. So for number 21, we can't solve it like that. We don't have to do like this because the repetition doesn't really matter, I think. Okay, actually, I don't know. I just confused myself. So if you guys want, you can check this like by using Google or something, or like ChatGPT. Like you can just take a picture of the problem and then check it. Yeah, because I'm not sure about this one, so I'm gonna check it later. But for you guys, check it so that like you guys are sure. So then for number 21, we are going to be doing a combination because she's choosing 6 random songs from an album. So it would be 14, 6. And then for number P, it would be for number 23, it would be P because Carl is choosing a 4-character password. And then the password can contain like only letters and digits only, and it cannot include repeating characters. So like this is like specifying us or like telling us that the order does matter. So we have to do the permutation. If the letters and the digits could like repeat, if the characters could be repeated, we would use a combination, but since the order does matter, we would use P. So it would be P, and then it would be P, and then 26 plus 10 would be 36, and then 4. Yeah, so we are looking for 4 characters, and then we have 26 letters like in the alphabet, and then the digits, if we're doing it from 0 to 9, they're 10, so 26 plus 10, 36. So yeah, and then 24, it's also a permutation because the order or like the amount of people that he's choosing are specifically 3. He's choosing 3 students to win like the specific awards. So we would use a permutation. So it would be P, and then it would be 26, 3, because the number and the order is set. So then for number 25, we would do a combination because it's just 7 random cards from a deck of 52 cards. So like it's not specifying what kind of cards or anything else, so the order doesn't really matter. There's no specifics. So it'll be 52 and then 7. And yeah, that would be it. And yeah, just for number 21, I would check that one. I'm gonna check that one. So you guys should too. Should check it as well, because I'm not sure. And yeah, that's it. So I hope this helped. And please check like the answers. Like no matter who gives you the answers, because even I can be incorrect sometimes, or other people can. So if you want your work to be correct, just check it. Like if you want, you can just check it in ChatGPT, like take a picture of it and like you'll solve it. That's how like I check my work sometimes. So yeah, bye bye.